Hello, class. Welcome to the second activity in Lesson 5 of Unit 5. All right, fractionally speaking, multiples of powers of 10. All right, so the question asks us to select all expressions that are equivalent to 0.6 times 0.5 and be prepared to explain your reasoning. Okay, so what's interesting about this is they haven't yet asked us to even find out what this is. Okay, they'll do that later on down here. We'll find out what it is later on. But we first want to understand what this means, how it works. Okay, so that's what's important about this. It's important to know that if you were to read this, I just read it to you as 0.6. You could also read this as 6 tenths, ending in th, right? This is also 6 tenths, same thing. 0.5, that's 5 tenths, all right? And so that means we're talking about it being out of 10, right? So that's important to keep in mind. Okay, if there are 6 tenths, then how many 1/10 segments would that be? There'd have to be 6 1/10 segments. So let's go through each of these here and see which ones are equivalent and which ones are not. So if we look at A, 6 times 0.1. Well, 6 times 0.1 is going to be 0.6, right? 6 times 1/10 is going to be 6 tenths, which is what that has. So that part's correct. And then times, because we are multiplying right here, times, okay, that's fine. 5 times 0.1. 5 times 1/10. Well, 5 times 1/10 is 5 tenths. That's what this is. So, yes, this is equivalent. All right, let's look at B. 6 times 0.01. Well, if you remember from the last activity, this is 1/100th. This would be 6/100ths. That's not this. This is 6 tenths. This would be 6/100ths. So we are going to put a big X next to that one. That's not going to work. For choice C, 6 times 1/10. Well, 6 times 1/10, that is the same thing as 6 times 0.1. We saw that in the last activity. This part's the same. Multiplying times 5 tenths, multiplying times 5 tenths. This is 5 tenths. Yep, 5 times 1/10. Yes, this is correct. Well, let's look at D. 6 times 1/1000th. Well, that's going to be 6 thousandths, ending in th. Well, that's not what we want. That's no good. Okay? Or it might be good for something else, for a different problem, right? But it's not good for this problem. And for letter E, 6 times 0.001. This means 1/1000th, which is way different than that, right? You can actually just see. This one may be a little easier to see. You can just see plain as day. No, this is not going to be the same thing. For F, 6 times 5. This is different order. Times 1/10 times 1/10. Let's see if you can notice something. Do you notice this over here, which we said worked? Do you notice how the numbers are the exact same? We have a 6, we have a 5, we have a 1/10, and we have another 1/10. The operation is also the same. They are multiplying throughout, multiplying throughout. When the operation is the same throughout and the numbers are the same throughout, it doesn't matter what order you do them in, okay? Now, if there were different operations, well, that's different. We know we have order of operations to follow. But when the operation is the same and the numbers are the same, it doesn't matter what order we do them in, which means that C and F, these are the exact same thing. The commutative property makes that so. Okay, we just moved them around, but we didn't change the numbers or the operations. And then for G, whoa, this looks very different. 6 tenths, right? 6 tenths. Oh, that's what that is. That's 6 tenths. We just said that, right? 0.66 tenths times 5 tenths. Yeah, that's what that is. This is the exact same thing. So it's important then to take a look at this. At some point, you may want to pause the video and just try to get a good impression of this in your mind so you understand how things can look different at first, but really mean the same thing. Now when we get to number 2, we're actually going to go ahead and find out what this actually equals. 0.6 times 0.5. So I'm going to go ahead. They want us to actually explain this in a little bit different way here. So instead of doing the way that I'm going to solve these pretty much most every time from here on out, for this time I'm going to do it a little differently. We said 0.6 is the same thing as 6 tenths. Right? And 0.5 is the same thing as 5 tenths. Let's work it out as if we set it up like this. Okay, so 6 tenths times 5/10. Okay, when we multiply fractions, okay, it is true that you can sometimes cross-cancel to make things a little bit easier. There are a couple of different ways to cross-cancel here. However, in this case, I'm not going to cross-cancel because I want you to see exactly how to make some sense of this here. So we're just going to go straight across for this one here. 6 times 5, that's 30, over 10 times 10, that's 100. Okay, so we're talking about 30 out of 100. 30 hundredths is what this is. So if you were to write that, you would write that as 0.30. 30 hundredths. This is the same thing, as you might have already been able to guess, as 0.3, right? So you can describe this as being either 30 hundredths, like this, or as 3/10. Okay, those would be equivalent fractions, right? If you were to simplify 30 hundredths, you would simplify it down to where it says 3/10, right? So these two mean the same thing. Okay, I wanted you to see it this way so you can actually see it's actually 30 out of 100. Okay, now there are other ways that we're going to do these problems, which we'll get into a little bit later on, which I think will be the norm for most of you moving forward. So let's get right to that. Let's look at number 3, part A. 0.3 times 0.02. Okay, so what we're going to do here, this is 3/10 times 2 hundredths. Okay, but what we're going to do, we're just going to go ahead and set this up as we're going to stack them and multiply them. All right, 0.02. Okay, this actually has more digits, and when we're multiplying, we do not have to line up the decimal points. So I'm just going to put the number that has more digits on top. So I'm going to put 0.02 up top, and then we're going to do times 0.3. Okay, so 0.3. You'll notice that now the decimal point, I didn't bother to try to line it up. It doesn't matter. Okay, here's all you're going to have to do. 3 times 2 is 6. The rest is going to be zeros all the way through. Okay, there's no reason to write all those zeros because what we have to do now is we just have to look at the decimal point here, and we have to account for how many numbers are behind a decimal point. So if you look at this here, on the top we have the decimal points here, 1, 2. And then down here, here's a decimal point, and there's another one, a third number that is to the right or behind the decimal point. So when we have this, that means we're going to have to move the decimal point 3 places to the left. We've kind of had practice doing that in the last activity, right? So we just counted the number of decimal points that were involved, and we went that number of places to the left. So that's what we're going to do here. We don't have a decimal point here, so that means that we're going to need to go 1, 2, 3, and I'm going to make the decimal point here, but you can see there's 2 blank spots, right? So in those blank spots, we need zeros. Okay, and then to the left of the decimal point, I'm going to put another 0 so we're clear that it's less than 1 that we're talking about. So 0.006 would be what you would get here. You could pronounce this as 6 thousandths. All right, so I think that part's a little bit new for a lot of you, 6 thousandths. All right, so for this next one here, same idea, 0.7 times 0.05. Let's go ahead and put 0.05 on top because it's got more digits. And because when we're multiplying, we don't need to worry about lining up the decimals. And then I've got 0.7, 0.7, okay. 7 times 5, we know that it is 35. So we can have 5, we can put the 3 up here. 7 times 0 is 0, plus 3 is 3. You could have also just gone ahead and put 35 here because in this case we know we have zeros. And you're going to count the numbers that are to the right or behind the decimal point. We have 1, 2, and then down here we have a third. So we're going to go 3 places to the left. There isn't a decimal point yet. That means it's at the end. We're going to go 1, 2, and then 3. So we need a 0 here, and then the decimal point to go here. And we can put a 0 in front of that. This 0.035 is 35 thousandths. All right.